Hi, this is the Atem channel, Atem Tooling Expressive Models, and my name is Lasse. Today I'm going to talk about CPS, a very important part of the Atem project. It's going to be pretty abstract and a bit nerdy and will give you a high-level overview over our technology. So what is CPS and why is it amazing? CPS is the core technology developed in the Atem project. CPS stands for Cascading Properties Sheets. It is very generic and can be used in a lot of domains. With the MOM, the Metapolator Object Model, we use it for parametric type design. But it can be used for really anything. For example, the Valentina project creates a free and open editor to design fashion patterns. We talked about making a parametric fashion pattern software for it using CPS. This is an important idea that I want you to understand. In fact, it is the important idea that I want you to understand. The tooling we do is for a big part designed so that it works with any domain-specific use case, not just type. And I hope that we can come up with many more use cases in the future for our stuff. To understand CPS, it helps to know that we took inspiration from CSS and HTML. There's an article on the Atem-Project website that explains more about this. You'll find the link in the video description and the video above the article, probably. As in HTML, which has the DOM, the Document Object Model, we have an object model as well. The object model represents the data we want to work with. It models the data, right? So for a specific domain like type design, fashion patterns, we need to create a specific object model. Such an object model is a tree-like structure, a graph with parent-child relations that is acyclic. That means we don't create relations that form a loop. A node can't be a descendant or ancestor of itself. An object model also knows how to use its data. The Metapolator Object Model, for example, knows how to draw its glyphs. That code belongs to the object model. But what it doesn't know is which values to draw. That's the part where CPS comes into play. The rendering code for a contour of a glyph asks CPS for the coordinates of the Bezier control points to draw. The purpose of CPS is especially logistics. It delivers values into the tree structure of the object model. It assigns properties to nodes so that the rendering code can read from there. For this, we use the same mechanism that CSS uses. Both CPS and CSS are organized in blocks of rules, which carry selectors and properties. The selectors associate rules with nodes in the object trees. The selectors really are a very flexible way of addressing nodes in the object tree. A rule also carries the properties that are assigned to a matching node. A property is a name and a value. A rule is very much like a dictionary for these properties. If many rules define the same properties, the rule with the most specific matching selector wins. Selector specificity is very important here. All rules that apply to a node are sorted by their selector specificity. If a rule does not define a property that is requested, the property is looked up in the next rule until it is found. This mechanism of falling back to the next rule is the cascading from the name Cascading Properties Sheets and also from Cascading Style Sheets. We took this part, the selectors and the cascading, from CSS because we wanted a system where one can apply very general properties to all of a font or even a font family, but then add overrides where the general properties don't yield the right results. CPS allows us to do that, to make very general definitions for many nodes, but also to control this down to the tiniest detail. So what is different from CSS? We don't have a fixed set of properties. In CSS, properties like background or font family are defined, and these properties have a very specific purpose, and each has also a special syntax. With CPS, we have instead a programming language called property language, and we can come up with any property names we like. Some property names, though, are expected by the rendering code, so we have to define these and ensure they have the right data type, like a number or a vector type. With the property language, we do essentially small math formulae or functions. We can also reference properties of the current node or other nodes in the calculation. All the properties that are applied to a node are basically the current variable scope of a formulae. This scope is created by the rules of specificity and cascading. Each property is essentially like a small function. To calculate the final position of a point in a glyph, we execute many of these small functions. So, when drawing a glyph, the program that runs is composed by the cascade mechanism. This is a novelty, as far as I know, and I think we should give this a name, like cascade programming or something. Yes, that's the whole thing. In a nutshell, a tree-based object model and CSS, but with programmable and referenceable properties. This gives us some great features. For one, we can create something like inheritance, where we copy the object tree, but transform the CPS values before we reuse them. This is how interpolation of fonts is done in Metapolator. We can also pin points to other points by just using references. This way, a serif could always stay attached to its stem, no matter how the stem is changed. Another not so obvious, but extremely nice thing is that the rendering code of our objects can be super simple. This is great because it makes it easy to write new types of objects. Like, I'm planning a plugin mechanism that makes it easy to include these new types of objects, and a lot of the tooling will work out of the box for these plugins. Think, for example, of a serifs plugin to draw custom serifs. CPS is like the glue that holds these objects together and makes them work seamlessly. In a way, plugins and new domain-specific object models are very similar. Both will profit from the tooling that already exists in the Atem-Project. Also, having this very structured approach makes it possible to write this kind of general purpose tooling without knowing what kinds of objects will be created in the future. Of course, there will be like specific tooling as well. But okay, that's it for today. I hope this helped you to get a broader idea of this technology, and I hope you got interested in it. If you have any questions, please use the comments and ask them. Also, I suggested cascade programming. If you got a better idea, please use the comments and suggest it. And if you know something similar, please let me know. Yeah. That's it. Thanks for listening. I'll do more of this, so subscribe. See you again. Bye bye.